So let's move on to the last and final type of substance that we need to name, and these are acids. Naming acids is a lot more complex because you have a lot more complex rules here. In order to name acids, remember at the beginning, we said that for what we're doing right now, all acids are going to have H first. So you see H, H, H. That's how we know it's an acid. So to name an acid, what we do is we look at the anion. The anion is the negative ion. Just a little side note, cations are positive ions. Okay, the T makes a plus sign, so that's how we know it's positive there. But for here, we're going to look at the anion. So I'm going to circle those in each of these examples. So those are my anions. Here I have a Cl, here I have an NO2 polyatomic, here I have an NO3 polyatomic, okay? If your anion ends in "ide," which this one definitely would, it'd be chloride, you're going to drop the ending and add hydroic acid. And so what we have here is we would have chloride, but we're going to drop that ending, and then we're going to add this. So this will become hydrochloric, there's my root, acid. Okay? For this one, NO2 polyatomic is called nitrite. So here we're going to drop the ending and add us acid. So we're going to drop the ite, and this will become nitrous acid. Okay? I always have students ask me here, what happened to the hydro? Where's the hydro? Hydro is here. It's in the rules. Okay? This word acid is what tells you this H is here. Okay? So the word acid tells you the H is here, not the word hydro. And so you really have to follow your rules here. For this one, NO3 is called nitrate. We're going to drop the ending and add ic acid. So this becomes nitric acid. Okay? To help you remember, do some little word association, okay? Itis goes together, okay? Like appendicitis goes together. And then adic goes together. And so a lot of times I'll say I ate it and I got an itis. Okay, so I ate something and I got sick. So that might help you kind of remember what gets put together there. So hydrochloric acid, nitrous acid, nitric acid. Common acids that you may use in your lab, definitely hydrochloric is a really common lab acid. Okay, so we talked about naming acids. Just like before, got some for you to try. You might want to pause your video and work on these. A couple of polyatomic ions that you haven't seen yet are coming up, so I just wanted to give you what those are. ClO4 has a -1 charge, and it's called perchlorate. It's a little more of a unusual one. NO2, we've already seen, nitrite. ClO is actually called hypochlorite. Hypochlorite. SO4 we've already seen, that's called sulfate. PO4 we've already seen, that's called phosphate. So just wanted to give you some of the ones that we hadn't talked about yet. So go ahead and pause it and try it. Okay, so you should have time to work on it and coming back. So if we look at this, remember for acids, we're always looking at the anion, and it's whatever's not hydrogen, okay? So here we've got F. We would normally call that fluoride. And remember the rule with ide is that you drop the ide and you're going to add hydroic acid. So HF is hydrofluoric acid. Okay, HCl, hydrochloric acid, HBr, hydrobromic acid, and so on. For this one, what's not H is this ClO4, which is called perchlorate. And remember the rule with 8s is that you drop the 8 and add ic acid. So this just becomes perchloric acid. No hydro because it's not in the rules, okay? Remember this acid is what's telling us that H is there. Last one, the NO2 is called nitrite. And remember the rule for itis. I'm going to drop the ite, and it becomes nitrous acid. All right. So we'll go a little faster here. ClO, hypochlorite. Drop the ite, so this becomes hypochlorous acid. Okay? A lot of times students see hypo and hydro and get them confused. They're not the same. This ClO polyatomic ion is actually called hypochlorite. So that's why the hypo is there, because it's there in the name. These last two don't follow the spelling convention, and they're two examples that I put on here on purpose because this is a common lab acid that you definitely need to know the name and formula of. So SO4 you would call sulfate. So looking at the rule, you would think it's sulfic acid, but it's not sulfic acid. It is sulfuric acid. So some don't really follow the whole just drop it off, add it on rule, and this is one of them. The other one that doesn't follow is the next one. So PO4 is phosphate. So it doesn't become phosphic acid, it becomes phosphoric acid. So these are the two that don't, that you can't just drop it off and add it on like we did with these up here. So sulfuric and phosphoric acids. Okay. Now we want to go backwards, just like we did before. If you have the name, how do you get to the formula? Notice 1H, 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 2 H's, 3 H's. So why do these just have 1H and why do these have 2 and 3 H's? That's a question you could kind of ask some of your students if you're looking at formulas. You know, why do you think these only have 1 and these have 2? Hopefully they might make a connection with ionic, which is what's going on here. And we'll talk about that in just a moment. So just like with ionic, we're going to do the whole cross down method because these are going to be like, you can treat them like charged particles. When you see the word acid, you're going to always write H plus as your first ion. Then you look at the name to decide what anion to write. So all these, I see the word acid, so I'm going to write H plus, H plus. And when we talk about acids and bases later on, we'll talk about why acids are H plus. And then here you kind of just look at what's been added on to your name. So hydroic acid has been added on. That goes with the ending "ide." So what we have is bromide. And so back from ionic, we know that bromide is Br. It has a -1 charge. How many of each do I need to make it equal 0? 1 of each, so it's HBr. With this one, what have we added? We've added ic acid. Ic corresponds to 8. And so we know our anion is chlorate. Chlorate is a polyatomic ion, ClO3 negative. Again, 1 of each, or +1 -1, so we need 1 of each, so HClO3. This one is us acid, so that's ite. And so our anion would be chlorite, which is another polyatomic ClO2 minus, +1 -1, so you need 1 of each, ClO2. Like that. So notice all these examples I gave, we have 1 hydrogen, and that's typically the case for most acids. Let's look at one that's not 1 hydrogen that we haven't already talked about. Let's do oxalic acid. So if I see this name, oxalic acid, it's really obscure, but it works for the example. Acid, so we would write H plus, and then we look at what's our ending. So it's ic acid, which corresponds to 8. So oxalate, oxalate is a polyatomic ion, C2O4, 2 minus is the charge. And so think back to what we did with ionic. This is +1, this is -2. How many of these do I need to make it 0? I need 2. Or you could do the whole cross down thing. So the 2 comes down with the H to be H2, and the 1 comes down with the oxalate, so you don't show it. And so this will be your formula. And so that's how we get to that. And later on we talk about acids. These are called monoprotic and this will be a diprotic acid. Because H+, and this kind of leads into the next lesson, which is on atomic structure. If you have hydrogen that's a positive ion, essentially all it is a proton, because hydrogen has one proton, one electron. So if it loses its one electron, it's just a proton. So this is why this is called monoprotic. It's got one hydrogen, which is one proton, diprotic, okay? And then the phosphoric acid would be an example of a triprotic acid. And this formula comes from H+, and then PO4, 3-. So when you cross it down, you get your formula. Okay, so acids, a lot more complex. You probably don't teach this with your students, but you probably use some of these things in lab, and it's important for you to know as a teacher, you know, where's this formula coming from, where's the name coming from, and be able to understand what all these little numbers are meaning.